Calc AB, summer packet number 1, sample problems worked out in class. Of arctan of -3/4. I'm a really big fan of using triangles for my unit circle rather than the unit circle. So I'm going to start by drawing the Cartesian grid and try to find a triangle. I know that the function arctan only exists in these two quadrants. So I have either a triangle like this or a triangle like that. I know that tangent is opposite over adjacent because of SOHCAHTOA. Raise your hand if you're familiar with the term SOHCAHTOA. Sweet, that's awesome. So tangent tells me opposite over adjacent. So I want to have from my angle an opposite side of 3 and an adjacent side of 4. The top triangle is +3 and the bottom triangle is -3 because I'm going down 3 units. So I know that the bottom triangle is the triangle of interest to me, -3/4. Now I want to take sine of that triangle. And sine is opposite over hypotenuse. So my opposite is 3 and my hypotenuse is, we have to figure out by the Pythagorean Theorem or the fact that we have our triangle 3, 4, 5 memorized because it's really common. So my hypotenuse is 3/5. If you did the Pythagorean Theorem, you'd get -3 squared plus 4 squared equals your hypotenuse squared, and you'd find it to be 5. Raise your hand on the scale of 5. I really get what you explained, and 1, I'm still totally lost. 3, 4. Okay. Good. There's mostly 3s and above. There's a couple in there. I recorded this, so you're welcome to go to the website and see it described again and hit the pause button. That's a really useful feature. You can't really tell a teacher too much. It's recording.
Okay, so first you're going to translate what cosecant. This is hard to read. What? This is problem number 20, and first you have to translate what cosecant and tangent are. So cosecant is 1 over sine, and tangent is sine over cosine.
Can you tell me why you're translating it to?
Because it's easier to simplify and it's more simple to see exactly what they are.
Trig identities, it's really useful to translate them all to terms of sine and cosine, unless the only thing you have is tangent and cotangent.
So after this, you make the common denominator so that you can simplify even more. So you're multiplying.
She multiplied this fraction by cosine, so that she had a common denominator, cosine sine.
And then you're multiplying sine times the other side, so it'd be sine squared x. So this is inside the parentheses, and on the outside, should I just write it on the bottom? Underneath?
Yeah.
Okay, you still have cosine x, sine x. So then, because you have the same thing on the outside, you can cross out the bottoms, leaving you with just cosine x minus sine squared.
Raise your hand if you understand what she just did. Sweet. And that's what you were trying to set it equal to?
Yeah.
I think it was.
Yeah.
Yeah.
Okay.
Sweet. Well done. 2 sine squared of x plus 3 sine of x minus 2 equals 0. I noticed that this is in the form of 2 something squared plus 3 something minus 2, which automatically makes me think it's a quadratic function. So I do a u substitution and say 2u squared plus 3u minus 2 equals 0. Basically, I didn't write it down, but I said let u equal sine of x. Because I don't like dealing in trig. Trig sucks. So let's deal in variables, because we've been doing that for years now, and it's much easier to do. Here's a quadratic equation. You could use the quadratic formula, or hopefully you're able to factor it. And I believe this factors to minus 1 plus 2. 2u squared plus 4u minus u minus 2. It does. Do you follow that factoring? Okay. So in order for this equation to equal 0, either the first piece equals 0 or the second piece equals 0. That's called the zero product property. And what I want to do is solve for u. So either u equals 1/2 or u equals negative 2. Now naturally, we can't stop there because our question was in terms of x. So what we have, in fact, is sine of x equals 1/2 or sine of x equals negative 2. And if we think about this, graphically, the sine curve bounces between plus and minus 1. So this will never happen. So we don't have to solve that piece. The other piece, however, does happen. So we need to ask ourselves, where does sine of x equal 1/2? Sine is opposite over hypotenuse. So we're looking for some sort of scenario where we have opposite over hypotenuse. And it's been pointed out that this is at pi over 6. And then we also have, you're saying 5 pi over 6? That also works. So our two solutions are pi over 6 and 5 pi over 6. If we wanted to give all solutions, which oftentimes we do, we ask ourselves, what is the period of the sine function? And it's 2 pi. So we can add 2 pi times some number n. So we not only do we have pi over 6, we also have pi over 6 plus 2 pi, plus 4 pi, plus 6 pi, plus 8 pi, etc. So what this is we're given a piecewise function asking us to graph the piecewise function. And the first piece is negative x squared if x is less than negative 2. The second piece is x cubed if negative 2 is less than or equal to x, which is less than or equal to 2. And the last piece is a linear function, negative 2x plus 1, if x is greater than 2. So we have 3 pieces. I'm going to start with the first piece. Negative x squared is a quadratic, it's a parabola, and the transformation that's happened is it's flipped upside down because the negative in front. So if I had no constraints, it would look something like that. But because I only want to graph it when x is less than negative 2, I have to erase to this point, and it stops at negative 2. Do you follow what I did there? So we're only graphing the curve if x is less than negative 2. If we go to the second curve, and if you're curious where that open circle occurs, you can actually plug it in and you'll find that negative 2 squared is 4, and then you get the negative value. So this should be down at negative 2 comma negative 4, if you're trying to be precise. And I love precision. The next piece is the cubic function, and We might remember cubic functions as looking something kind of like that. And it crosses at the origin. It actually also crosses at the ones, so 1, 1, and -1, -1. So my curve is going to look something like that. The exact value here would be, it goes down to -8. So -2, -8. And it's a closed circle because it includes the -2. And it goes up to 2, 8. And it's a closed circle because it includes the 2. So on this curve, I knew where 5 points were because I'm really comfortable with drawing cubics. If you're not comfortable with it, you can always plug the values in and get the answer. And that's the way you could do the third piece, which I'll do in blue. The third piece is the easiest to graph. It's a line. What's the y-intercept of the line? +1. And then the slope is -2. So it's going to look something like that. But we only want to start at the value of 2, which occurs, if we plug 2 in, we'd get -4 + 1, a -3. So at 2, -3, and it continues downward in that direction. So those are your 3 pieces, piecewise functions. And you should get really comfortable with piecewise functions because the AP test is all about them. They like giving you piecewise functions. So you may not need all 3 pieces all the time, but they like presenting things that way. She tackled the problem that way. There's other ways to do it. In my key, the way I did this was I started by writing it as the exponents like that, x to the third over x to the 1/2. And from there, I subtracted my exponents, which gives you x to the 5/2. Fewer steps. Maybe that makes it better. But she attacked it that way because that's the way she instinctually saw it to be solved and still arrived at the right answer. So both work. Right? E to the 4x over e to the third. Because our numbers are the same base, we can say e to the 4x minus 3, and you're done. There, that's all you can do. Number 6 on page 4, this is just practicing your factoring skills. It's asking you to simplify it. I look at the top piece, and I see that they all have a term of x in it, so I'm going to start by factoring out an x. And then I'm going to look at the bottom piece, and I can't do the same thing, so that's not going to work. I have to use a different method on the bottom piece. I am really akin, when I see 4 pieces and it's a cubic function, to doing factoring by grouping. Hopefully that works. So I take a look at the first 2, and I look at what's common with those. I have an x squared. If I were to factor out of those first 2, then I would get x minus 8. And then for the second 2, I'm hoping that I can get an x minus 8 piece. If I can't, then I can't do factoring by grouping. Fortunately, if I factor out a -2, I can. Which means my denominator, when I simplify that all out, I get x squared minus 2 times x minus 8. Factoring by grouping is a difficult skill that a lot of people forget about. But that's the denominator. The numerator will factor to x minus 8, x plus 1. And then you can cancel the x minus 8s. So you finish with x times x plus 1 over x squared minus 2.